Okay. So in yesterday's class, we looked at how a root switch is elected in a network of layer 2 switches, right? To elect a root switch, there is an election criteria that takes place between the switches. And that criteria is whichever switch has a lowest spanning tree priority that takes over the role of root switch. And if the priority is a tie, then whichever switch has a lower MAC address, it takes over the it takes over the role of root. Now, once the root switch is selected, the next is the spanning tree elects root port on all the non-root switches, right? So the condition for a root port election is can be multiple root ports to reach a root switch on a non-root switch. So whichever port has a lower cost to reach the root switch, it takes over the role of root. Now, if the cost is also a same, if cost is also a tie, then the lower MAC address, the neighboring switches lower MAC, whichever neighbor switch has a lower MAC address, that particular port takes over the role of root port. Then designated port on all the non-root switches. All the ports except the root port on non-root switches are designated port, and all the ports of a root switch are designated. Okay, it's that is very simple. Then block port. Right. Obviously, to avoid a block port, we to create a block port or to create a loop-free environment, we need a block port. Right? And a block port is always elected between the switches where they have a connectivity with their designated ports. Okay. So we're here in this example, the designated port of switch number 2 and the designated port of switch number 3 are connected together. So out of these two switches, one has to convert its interface to a block port. Right. So the conversion takes place when the either of the switch has a higher cost to reach the root switch. If the cost is also tied, then out of these two switches, whichever has a higher MAC address, that takes over or that converts a designated port into a block. Right? And then what happens is that here we saw how different switches are taking over the role of or giving the role of root port, block port, designated port, etc. Right? And now we'll see this in the form of let's look at this from a practical point.
So this will be that bigger diagram or a small one?
A smaller one with 4 switches, not 3 switches.
Not that 7, 8 switches like that.
No, no, because it's unnecessarily complicated. Now, if you remember, I said spanning tree on Cisco switches is enabled by default. Okay. So currently between these switches, we will see spanning tree running already. Okay. So the moment we connect these switches together, okay, currently the switch interfaces are, are yellow in color, and slowly they are converting their interface to green. Okay. And we will see one of the interface is still yellow. That means it's in a blocked state. It goes into the blocking port. Okay. And how does it go into a blocking port, which is a root switch? Everything will decide. But before that, on switch number 1, if I just do a show spanning tree active, we will see some information about spanning tree. I will explain all this information later. Okay. But as I said, spanning tree on Cisco switches is enabled by default. You don't have to do anything. Okay. The moment I connect these switches together through a physical interface, the spanning tree starts to run. Right.
So
Now,
what is the meaning
to
of active?
where?
Spanning tree
Yeah,
active
yeah.
is command.
As
What is the active meaning?
I'll explain that everything later. But let's just go step by step of what we had learned yesterday.
Okay.
Now, first, let me remove spanning tree from all these switches. Okay, so switch number 1. Okay, configuration terminal. I will remove no spanning tree. Then on switch number 2, don't worry about that command which I have wrote. I will explain that later. Configuration terminal, no spanning tree, VLAN 1. Switch number 3, enable configuration terminal, no spanning tree, VLAN 1. And on switch number 4, also enable configuration terminal, no spanning tree, VLAN 1. Okay. So currently on all these switches, there is no spanning tree that is running as of now. Okay. And let me just simply connect one PC over here. Okay. And currently you will see all the lines, all the green triangles are stable. Okay. Currently they're stable. Now let me just add an IP to this particular PC, 10.0.0.1, for example, and you'll start seeing these triangles, green triangles, they're blinking. Okay. So what happened is that when I added an IP to this PC, it sends a GR. We'll talk about GR later. Okay. It sends you can just think of it as an announcement message. Okay. It sent out an announcement message saying that I have this this is my IP and this is my MAC address. This is the announcement that the PC0 makes. Okay. Now let's see what is actually happening. Okay, I cannot show you in the simulation mode. However, right now you can see these information are these triangles are blinking. Now let's check the MAC address of this PC. MAC address of this PC ends with 714. Ends with 714. Okay, and let's open the MAC address table of switch number 4. Switch number 4. Okay, so and show MAC address table. You can see 714 is currently seen on 0/1. Then again, now you can see it is seen on 0/2. Then again for 0/2, 0/1. Then again 0/2, 0/2, 0/1, 0/2, etc. So we can see the same MAC address is seen on 0/1 and on 0/2 as well. Similarly, let's go on this particular switch and do a show MAC address table. Right, 714 is seen on 0/1, and what happens the next 0/1? Now you can see it is seen on 0/2, 0/2. Okay, then again 0/1, 0/1. So it is being received on both the interfaces. Okay, and we know that when we were understanding what is a loop, we understood that if the same MAC address is received on two different interfaces of a switch, if the same MAC address is received on two different interfaces of a switch, that means there is a loop in the network. And what happens because of a loop? These things are happening. Multiple copies of the same data is circulating in the network. Multiple copies, they do not reach the destination. And you can clearly see if those copies reach the destination, you will not see the loop. Correct? Then MAC table is unstable, we just saw. And CPU utilization of the switch increases. I cannot show you the CPU utilization, but just understand the CPU utilization of the switch is increasing. And collectively, this is called as a broadcast storm. All right. And so this is how you will see a loop in the network. Simple definition of a loop. If someone asks you what is a loop, tell him or her, if you see the same MAC address on two different interfaces of a switch, then there is a loop. Simple. You don't have to explain the whole broadcast storm scenario. Okay, CPU utilization will increase, this, that. No, just tell them if the MAC address, if the same MAC address is received on two different interfaces of a switch, then there is a loop in the network. Simple.
Okay.
Now
Yeah,
to
got
stop, yeah, now to stop the loop, let's bring back the spanning tree configuration terminal, spanning tree, that one. We'll wait for the interfaces to turn green. Let's note down the MAC addresses of each switches. Now, because we'll go step by step of finding out which is a root switch, and on the non-root switches, our root port is selected, our designated port is selected, and how is the block port elected. We'll go through all those steps one by one. And to see the MAC address, just do a show version. Okay. This is the MAC address. When you do a show version, okay, you will see base Ethernet MAC address. This is the MAC address of this switch. Okay. There are MAC addresses on the interfaces as well. There are MAC addresses of the switch also. We are not looking for the interface MAC address. We are looking for MAC addresses of the switch. Okay, so this is switch 1. Show version. Switch 2, switch 3, MAC address would be okay. Now let's try to find out the first thing. Okay, which among these is the root switch? So if to check the priority, okay. So let's do the check the priority of this switch for spanning tree priority. If you do a show and show spanning tree active, when I do a show spanning tree active, it means what are the active spanning tree running on the switch. There may be multiple instances of spanning tree. We'll discuss multiple instances of spanning tree later, but there can be multiple instances of spanning tree running. Few of them may not be running, few of them may be running, right? So this show spanning tree active gives us the active spanning trees that are running, or active instances of spanning tree that is running on this switch. So when I do a show spanning tree active, again, let's leave all these details for now. Just concentrate on one thing, that is 32768 over here, which is the priority. Priority 32768. Okay, we know that this is the default priority of the switch, of a Cisco switch, right? So show spanning tree active. You can see again the default priority is 32768. show spanning tree active. Again, we'll see a default priority of 32,768. Okay. And for switch number 3 also, we'll see the same, or switch number 4 will also see the same priority. Now, when the priorities are tied, when we know that when the priorities are tied, we look for the lower MAC address, right? So I've noted down all the MAC addresses of these switches. So let's find out which of them is a lower MAC out of these four. We know that the MAC addresses are compared from left to right, right? You can see the first two hexadecimal digits of each switch's MAC address is 0. So again, that's a tie. Then one, we have these four. Okay, obviously D is the highest of them. So that is out of the race, right? 3 and 4, right? They are larger than 1, correct? So 3, 4, and D are larger than 1. Out of these four switches, this digit is the lowest of them, and hence this switch's MAC address is the lower MAC address, and hence switch number 1 will be the root switch. Let's check. This is switch number 1 over here. This is switch number 1. Let's open that up and let's do a show spanning tree active. Okay. When I do a show spanning tree active, you will see spanning tree, right? Root ID. This means root bridges ID. It says the priority is 32,769. Why is it 769? We'll talk about that later. Okay. Consider this as 32,768 for now. The priority is 32,768. This is the root switches MAC address. This is the root switches MAC address, and you can clearly see it says this bridge is the root. This bridge is the root, which completely satisfies or proves our analysis that switch 1 is really the root switch over here. Okay, let's check what will be the information present on other switches. So you can see it says root ID and it says the cost. What is my cost to reach the root switch? It does not say I am the root switch. Only the root switch will say I am the root switch. This bridge is the root. It says I am the root switch. But other non-root switches will not say they are the root switch, but instead they will say what is their cost to reach the root switch. Okay, what is their cost to reach the root switch? This is what they will say. All right. So root switch is elected. Let me note that down. This is the root switch. Okay. Now the next is we will find out the root ports. Correct. We will find out the root ports. So obviously, from our earlier discussions, we can easily understand that for, let's go for switch number 2. For switch number 2, this is one interface which can be a root port. This is one interface which can be a root. It can reach the root switch via this way or via this way. Obviously, this will have a lower cost. Obviously, the direct connectivity will have a lower cost. Correct. So, and why will it have a lower cost? Because if we just open up this thing, you can see the cost on interface 0/1. When I do show spanning tree active on switch number 2, it will also show me the spanning tree cost of these interfaces. Spanning tree cost for these interfaces. On all the fast Ethernet interface, the spanning tree cost is 19. The spanning tree cost is 19. So to reach the root switch via this, the cost is 19. From here, it will be 19 plus 19 plus 19. Obviously, 19 is lower, right? And hence, this interface will become the root port for switch number 2. This is root switch. Similarly, for this switch also, this interface would become the root port. Clear? Is any are there any doubts till here?
No, till now it is clear.
Yeah. Now, for switch number 3, 19 plus 19, 38. 19 plus 19, 38. Both are same, right? If both are same, if the cost is a tie, then we go for the next election criteria.
Mm,
Which
ma-
neighbor switch has a lower mark? Which
MAC.
neighbor switch has a lower mark? So switch number 2 and switch number 4 are the neighbor. So let's go. Switch number 2 and switch number 4, right? So switch number 2, 0, 0. Switch number 4 also 0, 0. This is 4, 0. This is 3, 0. So obviously 3 is lower than 4. So switch 4 interface, whichever interface is connected to switch number 4 is, that is the root port. That is the root port, right? So let's check or verify that on this thing. So when I did a show spanning tree active on switch number 3, right, you can clearly see it mentions 0/2 as the root, meaning that's the root port. Fast Ethernet 0/2 is the root port. Okay, that is clear. Now, on all the non-root switches, you have elected a root port. On root switch, yeah, root port. The next is elect designated port, right? Once a root port is elected, we will start to elect designated port. And we know that all the ports except the root port are designated. So switch number 2, when we do a show spanning tree active, you can see there is one root port and the rest of the interfaces is a designated. Similarly for switch number 4 also, when we do a show spanning tree active, we will see one root port. Okay, that is this interface is a root port, and all the other interfaces 0/1, this interface is a designated port. 0/3, which is connected to the PC, is also designated because all the other ports are designated. Okay, it does not matter where is it connected, it has a connectivity towards some device, and except the root port, all the other ports are designated ports. But on a root switch, we discussed yesterday, on a root switch, all the interfaces are designated port. All the interfaces are designated port on a root switch, and you can clearly see it says this bridge is the root. Switch 1 is the root bridge, and all its interfaces are designated port. Clear? So
Yeah.
this is designated port, designated port, designated port, designated. Okay. Now the next is, this also becomes a designated. Now the next is elect a block port. Elect a block port, and we know that we go to find, or we will be, or the switch will be finding a block port where there is a designated port to designated port connectivity. One of them needs to come, one of them needs to change their designated port to a block port, correct? And for that, the first is higher cost. Whichever device has a higher cost to reach the root switch will convert its interface to a designated. So you have a DP over here, you have a DP. So between these two, one of them has to convert its interface to a block port. So the cost for switch number 2 to reach the root switch is 19. But for switch number 3, it's 19 plus 19. So switch number 3 has a higher cost. Switch number 3 has a higher cost to reach the root switch, and hence it will convert its designated port to a block port, and which is why we see an orange over here. Okay, let's open up switch 3, and you can clearly see it mentions block. The state, we'll talk about state later, but we can clearly see it mentions block. It is blocking.
Got it.
Okay, so this is how a spanning tree protocol will create a loop-free environment. So through this interface, data will not be sent, and through this interface, data will not be received. So basically, this link is virtually not present there. And hence you can see a loop-free network. Clear? Any question?
Yes, that's clear.
Yeah. Okay. So moving on.
In that, if we connect in middle, what will happen?
Where?
Image. In this one, if I connect this switch, what is it? Switch one, and switch down right side. What is it? Switch 4, right?
This is 1, 2,
1
3,
and
and
3.
4.
So if we connect 1 and 3 now,
Huh.
now how will we do the same
Okay.
process? Is it?
Let's check. Okay. Before I connect, think what is going to happen.
Like one more path will increase here.
Yeah.
So
1.
between this.
Now
And
see,
now,
again, there is an election happening. Okay. I'm not sure you can see. You can see all the interfaces have turned green, orange. Why?
yes, okay, all
Why?
three are.
Yeah. Why? Because previously this was a root port. This is how it was reaching the
So now it
root
has a
switch.
one more
But
short
now
path
there is a
also.
direct connectivity. So obviously this interface will become the root port.
Okay,
These
then
two will become designated port.
out of these designated, now the selection will be for
This
another
guy
path.
is also designated port. This guy is also designated
Okay.
port. Okay.
Now it is
Now
with
again DP-DP connectivity is there.
here also DB connectivity is at this
Yeah,
side.
here also DP-DP, here also DP-DP. So you have to elect a block port. Okay. So let's open up switch number 3 and see what is happening. So show spanning tree active. You can see two blocked interfaces are.
Oh, now it will block two places.
Yeah.
Okay, this side also, if you block one, then this side also will be a continuous. Okay, so it has to block two.
Yes. Because here also it's
So
DP. This
one
is
triangle is
DP.
there, one triangle is here. If you
DP. Yes.
block other side, this side will be circle. So it has to
Yes.
go this side as
Yes.
well.
Yes.
Got it. Yeah.
Got it. And let's check why are these two a block port? Because, okay, here you have a DP, here also you have a DP, this is also a DP, this is also DP. First criteria is higher cost to reach the root switch. Obviously, these two are directly connected.
That we got. So that
Obviously, so this is indirectly connected.
yeah, this will have the higher cost. So these both ports will go.
Exactly. No, give me a minute. No, not through that. Okay. The cost to reach the root switch is same. This is 19, this is 19, this is also 19.
Oh, this also, yeah, right. This also has a
This is
center
also
one.
19, right? This is also 19, right? Now, between switch 3 and switch 4, which is a higher MAC address? Switch 3 and switch 4. Let's check that.
4 is the higher one.
Let's check that.
So it
Switch
was
3 and switch 4. Switch 3 has a higher MAC.
3 has the higher. Okay.
Similarly, for switch 2 and switch 3,
So,
switch 3 has a higher MAC
those 3 only is having higher from both sides.
from both sides. That is why.
Okay.
That is why these two interfaces become a block.
Otherwise, if the MAC was less, then this side would have become block.
Correct. The other side would have taken the block port row. All right, clear?
Yes. Yeah.
Yeah. Now, let's go to our discussion on, let's continue our discussion. So let's, instead of taking 3 switches, let's now start discussing based on 4 switches. Okay, so switch number 1, switch number 2, 3, and switch number 4. Okay. Again, let's assume 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. Okay, so this guy becomes the root switch. Okay, these are the root ports. Okay, for switch number 3, This is also a root port, and this also is a root port. Okay, but it has to find out which one of them has to become a root port. Okay, so cost is going to be same from both sides, right? So next it will look for which neighbor switch has a lower MAC address. So obviously this interface becomes the root port, and this will become a block port later on. Okay, because this is DP, 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 and DP. This was also a DP, but then it changed to block port. All right. Any question? Understanding the diagram?
No, I guess.
Yeah. Now, as we were discussing, what if this interface is already blocked? It is not sending any data. It is not receiving any data. Correct. Now, what if this link goes down? When this link goes down, there is no reception or transmission of data. Correct. That means this particular switch or switch number 3 is now isolated. None of these switches can reach switch 3. Similarly, vice versa, switch 3 will not be able to reach the other 3 switches as well. Right? So there should be some mechanism which will help switch 3 connected to the rest of the network. Correct? Now, we will understand something called as a direct. Okay, I'll talk about this later. Okay, I'll talk about this later. Sorry, I'll talk about this later. But first, we have something more important to discuss before this thing, and that is again whatever we discussed, that the switches, right? Whatever we can see here, the switches are how the root switch is elected. Root switch is elected based on the MAC addresses or the priority. Whichever switch has a lower priority, it will take over the role of root switch, right? Whichever interface has a lower cost to reach the root switch, that takes over the role of root port. Whichever switch has a higher MAC address or a higher cost to reach the root switch, that takes over the role of a block port, etc. We discussed all this. But one question that still is not answered is that how do these switches know each other's MAC addresses? How do these switches know each other's priority? How do these switches know each other's cost to reach the root switch? Because until and unless these information are exchanged, the MAC addresses, the priority, all these are exchanged between the switches will never be able to elect anything, right? So there should be some exchange mechanism that takes place between the switches in the network, through which they are making these decisions of electing a root switch, electing a root port, finding out designated port, and finding out block, right? So until and unless there is a exchange mechanism, information exchange mechanism, these spanning tree will not be possible. And that exchange mechanism is called as a BPDU. Full form is Bridge Protocol Data Unit. Bridge Protocol Data Unit. Okay. We also call it as spanning tree BPDUs. Simple. We call it as spanning tree BPDUs. It's a protocol data unit or a bridge protocol data unit. Now, let's understand what does protocol data unit. What does a protocol data unit mean in terms of networking? Imagine protocol data unit as a language. As a language. Okay. So we have different languages. We have Chinese. I'm speaking English. Okay. In India, we have so many languages. We have English. We speak English, Hindi, Tamil, and many other regional languages as well. Right. Now, if a Chinese person or a person who speaks Chinese, if he wants to communicate in Chinese, He needs another person who can understand Chinese. Then only there will be a communication. Correct? Similarly, an English speaking person can speak to an English understanding person. Similarly, a person who speaks Hindi can speak to someone who understands Hindi. And the same goes for any other language as well. Correct? So you can think of these languages. You can think of these languages as PDU, which is Protocol Data Unit. So imagine Chinese language as one protocol, English as one protocol, Hindi as one protocol, Tamil has one protocol. So there are different protocols in networking, which we will learn later in the course. There are different protocols in networking, and all these protocols speak their own language. Okay, they speak their own language, and in that language they share each other's information. So similarly, for spanning tree also, there is a language. There is a PDU, which is called as bridge PDU. We just saw on the root switch number 1, it says this bridge. Bridge, earlier, switches were called as bridge. The first term that was given to a switch, it was not called a switch. It was called as a bridge. It is a bridge to connect different devices. That is why it was called bridge. And this same term has been passed down generations after generation, even after evolution of networking so much, right? So it's actually switch protocol data unit. It should be called a spanning tree protocol data unit, but no, it's still called as a bridge protocol data unit. Okay, and we will, as we will proceed with the course, we will learn different protocols, routing protocols, networking protocols, which speak their own language, right? Their language will be called based on that protocol. Okay, so protocol data unit in networking is actually a language for a specific protocol. Okay, so spanning tree has its own language which it uses to exchange information, and that language is called as bridge protocol data unit or BPD. Clear?
Yeah.
Now, switch 1, switch 2. Imagine these two switches are enabled with spanning tree protocol by default. We just saw that on a Cisco switch, this spanning tree protocol is enabled by default. Right. Now, the moment you connect these two switches, spanning tree will start to run between them. Spanning tree will start to run between them, and they will exchange these BPDUs between them. BPDUs between them. Switch 1 is going to send its own BPDU. Switch 2 will also send its own BPDU. Now, what are the information present inside BPDU? Okay, what are the information present inside the BPDU? First is what is the, okay, first of all, when two switches are connected together, okay, and as I said, the spanning tree starts to run, they will assume themselves as the root switch. They will assume themselves as the root switch. So when switch 1 is sending the BPDU to switch 2, it will call itself as the root switch. So inside this BPDU, the information that is present is first, what is the root switch's priority? What is the root switch's priority? Which is by default 32.768. Then second, what is the root switch's MAC address? Okay, which is obviously switch 1's MAC address. I'm just assuming that to be 111. All right. Then third, okay, the third is advertising switches priority. Okay, so imagine that there are multiple switches. Okay, multiple switches connected like this. Okay, so you have switch number 2 over here, and this is switch number 1. So we say this BPDU is forwarded between different switches, right? So when this intermediary switch is forwarding the BPDU, it will add its own priority. Not add, it will advertise its own priority. Okay, so advertising switches priority. Now in this diagram above, switch 1 is the root switch. It is assuming itself as a root switch, and it's the one who is advertising this BPDU. It will say my priority, its own priority as 32,768. Okay, then fourth, advertising switches MAC address, which is again 1111. And fifth, cost of this advertising switch to reach the root switch. Since switch 1 considers itself as the root switch, the cost is 0. Is this clear? The information that is present here. Is this clear?
This part is not clear. The third and fourth.
Third and fourth, yeah.
So when is it advertising? This just be connected 1 and 2.
So let's go back to our diagram over here. Okay. So imagine switch 1 over here.
Okay.
Okay. So switch 1 is a root switch. It is forwarding its own BPDU. Switch 2 will receive it. Switch 2 is forwarding the BPDU to switch number 3. Now, in this time, what happens? Switch 2 is the advertising switch. Switch 2 is the switch which is advertising this BPDU. When switch 3 receives this BPDU and forwards it to switch 4, it will say, it will add its own MAC address and priority in the third and fourth point, which I mentioned over here.
Okay, advertising project, like it's okay.
Got it?
Okay.
But since there are only 2 switches involved, and as I said, the 2 switches are assuming themselves as a root switch, the priority and the MAC address is of the same switch again. So let's cross verify this with switch number 1's BPDU. Okay. So you can see here, it says root switches priority 32,768. Don't worry, why is it 69? Okay, I'll talk about that later. Priority is 32,768. MAC address. This is root switches MAC address. Okay. Then bridge priority. This is again, whichever switch is advertising the BPD, it will add its own priority. But since switch 1 is advertising it, it's calling it as 32,768. And advertising switches MAC address, you can clearly see this, right? Then cost to reach the root switch. Cost to reach the root switch, which is 0. It says this bridge is the root. So basically, this is what goes inside your BPDU. These are the 5 important things that goes in with your BPDU. These things also go, but I will talk about them later.
Okay, so means first 5 lines goes there.
First 5 lines, these first 5, no, this also goes. This also goes, but I'm not explaining that. But I'm not explaining that as of now. Okay, so but okay, to remove the confusion, let me also write that as 6 hello timer, dead timer, and forward delay timer. I will explain these timers later. Okay, I will explain these timers later. But these 5 things are very important. These 5 things, along with the 6th thing, also go in the BPDU. Okay.
But the first 5 is important.
First 5 for now to understand is important. Okay. So in an interview, if someone asks you what are the information that is present in the BPD, you're supposed to say all these 6 things. Okay, you're supposed to say all these 6 things, but for an understanding purpose, I'm explaining only the first 5 for now. Right. Now, switch 2 will also send its own BPD, correct? So switch 2 will say the root switch is priority. Okay. Switch 2 will also say root switch is priority, which is again 32.768. Root switch is MAC address for switch 2 is 2222. Advertising switches priority, that is 32.768. Advertising switches MAC address, which is 2222. Okay, and cost to reach the root switch. As I said, switch 2 is assuming itself as the root switch. The cost is 0. Please remember, why is switch 2 assuming? As I said, the two switches are connected together for the first time. So switch 1 and switch 2 both are assuming themselves as the root switch. Okay. Switch 2 is also going to send, as I said, switch 2 is also going to send its hello timer, its dead timer, and its forward delay timer. As I said, I will explain these timers later. All right. But however, for the election purpose, who will become the root switch? Which interface will become the root port? Which interface will become the designated block port? The timers do not play a role. That is why I was emphasizing on the first 5 parts, first 5 points. The timers do not play a role to decide which is the root switch, or they do not play a role in the election purpose. Okay. However, these timers also go in the BPD. They are exchanged between the two switches. But for election purpose, only the first 5 details are important. Clear? Any question
Yes.
till here?
Yes, yeah, clear, clear.
Now, the moment these BPDUs are exchanged between the switches, switch 2, switch 1, switch 1 will receive the BPDU from switch 2. It will see the priority. Okay, priority is same. Let's go to the next tiebreaker, that is MAC address. Obviously, my MAC address is lower than switch 2's MAC address, and hence I will be the root switch between the two of us. Clear? Now, when switch 2 receives the BPDU, it will check the priority 32.760. Okay, it's a tie. Then the next 2222. It knows that my MAC address is greater than switch 1's MAC address, and hence I cannot be the root switch. I will become the non-root switch. I will become the non-root switch. Clear?
Yeah, it's clear. Yeah.
So
So
this is
checking this
how.
message only, they decide automatically.
Yes. So imagine not with just two switches, there are multiple switches. So they are exchanging BPDUs with each other. And based on the BPDU information, they are coming to know which is the root switch, which is the non-root switch. Okay, which will be the root port. Okay, so let's go back to our diagram over here.
So that itself will cause the broadcast storm, right? If they keep on exchanging messages like this.
No, obviously that BPDU exchange needs to. Was there a link between? I think so, yes.
I guess it was not there. I think between this and 7, I think it was there. 8 and 7. Four and 3.
Probably like this. Okay, anyway, not a big deal about it. Okay, so this is the diagram that we had, right? So now, when all these switches, when all these switches are connected together at the same time, as I said, all these switches will assume themselves as the root switch, correct? all these switches will assume themselves as the root switch. Right? They will start to send BPDUs. He will send BPDU, he will send BPDU, even 2 will send BPDU. So what is happening? BPDUs are getting exchanged between them. When BPDUs are getting exchanged between them, obviously they will find out each other's MAC address. They will find out each other's priority. And based on that, they can easily find out who is going to be the root switch. Eventually, switch 1 will become the root switch because it will have a lower. Got it? Because this BPDU, all the BPDUs from switch number 5, the BPDU is forwarded to 9. 9 will forward that BPDU to 7. 7 is going to forward it to 1. 1 is also going to forward its BPDU across the network. So all these switches will come to know about each other's MAC address. They will come to know about each other's priority. Yes, it's a broadcast storm, but eventually the broadcast storm will end when there is a loop-free environment.
Okay. Oh, got it.
Right?
So
When there's
these messages will stop after the route is elected and the paths are blocked, everything.
exactly.
Okay. So till
Okay,
that
not
time
even
only
that.
this.
See, I'll tell you. Okay, now the concept of a BPDU is only the root switch will generate. Only the root switch will generate the BPDU. So let's imagine between 5 and 9, 5 and 2, okay, it generated a BPDU. Between them, there will be some kind of election. Who is going to be a root switch? This 9 is going to forward the BPDU, 7 is going to forward the BPDU. Eventually, they will come to know one of us has a lower MAC. 5 has a lower MAC. So this for some fraction of seconds, 5 is the root switch. So 9 will eventually stop sending BPDU because it is not the root switch. Between 5 and 2, there will be an election for some fraction of seconds, and 5 will realize that between 5 and 2, 2 has a lower MAC, so this guy becomes the root switch. So 5 will stop sending BPDUs. Similarly, as and when there are elections between multiple switches, and whichever switch has a lower MAC or whichever switch starts becoming the root switch one by one, only that switches BPDU will be flowing across, and eventually it boils down to switch number 1. Switch number 1 is responsible to send the BPDU, and other switches will just forward that BPDU to other switches. Clear?
Okay. So suppose this we connected this initially. Okay, 1, 2, 3, 4 till 9 switches we connected initially with that, and then so immediately they will start sending BPDU. So 9 will send in the left side to 5, to 4, to 2, and to 7. So and 7 also will send left, right, down to 8.
Yeah, let's just
So
concentrate on one switch. Okay,
so
let's just concentrate from
okay.
one switch's perspective. 9 is going to send here, 9 is going to send here, 9 is going
To
to send
all
here.
sides sent. Okay.
And
So
also
now
it is going to receive from here, from here, from here, and from here as well. Now, between 9 and 5, it will understand that 5 has a better MAC address.
okay.
5
So
has a leave even that. Between 5, 9 is sending BPDU to 5, 9 is sending BPDU to 7, 9 is sending BPDU to 4, 9 is also sending BPDU to 2. 2's MAC address is received by 9. Correct? 2's MAC address and priority is received by 9. 2 will automatically understand that 2 has a better MAC address than me. So obviously 2 will become the root switch. So now what 9 is going to do, 9 is actually going to forward the MAC addresses or BPDUs of switch number 2 to other switches. Eventually, 2's MAC address will be known by 5, which has a higher MAC address than 2. 2's MAC address will be known by 4, which has a higher MAC address than 2. 2's MAC address will be known by 7, which has a higher MAC address than 2. So obviously 5, 4, and 2, 5, 4, and 7 will eventually know they cannot be the root switch.
So they will think 2 is the root switch.
2 is the root switch. When 1 sends its BPDU, it will be forwarded, it will be forwarded, it will be forwarded, and eventually it will reach 2. 2 will now then know it cannot be the root switch, so it will stop sending the BPDs. Got it? So this is how your BPDs are exchanged between the switches. And yes, initially there will be a flood of BPDs, but as the roles of each and every switches are identified, they will stop sending the BPD. Clear?
Okay, yeah, clear, clear. So initially only it will be a problem for some time. After once the
Yeah,
route is selected, then it will
but that also
okay.
were very like not even few seconds.
So till that time, the CPU usage will also be very high.
Uh, Not too high because it's not
It
data.
will
It's
process.
just
It
a
will
very
process
small,
that
very small.
matching,
Yeah,
comparing the MAC address, like that.
correct, correct. Okay, for few seconds there will be flooding. Okay, but for few seconds
Then
there
after
will
that,
be, and then there will be, it will be not.
okay, yeah, got it.
Okay, but at least it's not prolonged,
Yeah, it will
not for a
continuously
long
not
time.
block the network. Yeah.
Yeah, just for few seconds. Okay, and obviously until unless like when you are powering on the switch, you will know that it's like there will be no data on that switch. Okay, there will be no data because there are new switches. You're just connecting them to the devices. Okay, so when you are connecting them to the devices, obviously there is no data flow. You will start the data flow only after your spanning tree is done, and then you will start connecting different PCs to these switches, and then you'll start to send data, right? So the initial time when there is a broadcast storm, your data is not affected. It's just the broadcast storm of a BPDs, not anything else.
Okay. Okay. Sure.
Okay, it's already 11:30. So as I said, we'll discuss this timer. We'll discuss this timer tomorrow, and then we'll continue on the spanning tree discussion.
Okay.
Any
So
question till here for today's class? Any question?
uh, till now, yeah, it is clear. After seeing the lab thing, it is clear.
Okay. So, so here, what see between these four switches also, they would have exchanged BPDs. They would
In
have
the
exchanged
initially beginning.
initial stage. They would have exchanged BPDs with each other. That is why they came to know that switch one's MAC address is lower, and that is why switch one has become the root switch.
So all those 5 points which we were doing manually to understand that, those five points are used by the switch CPU to understand after getting the message. So
Correct, correct.
whose priority is less, whose MAC is less,
Yes, it is because of this BPD only.
which is having the cost more or less.
Yes. So what happens is switch understand from switch two's perspective. BPDU, as I said, BPDU is generated only by the root switch, whichever switch becomes the root switch. Okay. Let me delete this first. Okay. Now, switch one becomes the root switch. Okay. It starts to send the BPDs. Sorry. It starts to send the BPDs. Now, when switch two receives this BPD, okay, root switch is going to say my cost to reach myself is 0 because it's the root switch. Similarly, he will also say my cost to reach the root switch is 0. Right. Now, switch two, it knows its interface cost is 19. Its interface cost is 19, and it is receiving the BPD directly from the root switch because the root switch priority and MAC address is same as advertising switches priority and advertising switches MAC address. Both are same. So switch 2 knows that it is directly connected to the switch. It is directly connected to switch. Now, so it knows this interface span tree cost is 19. Right. Now, switch 2 is going to forward this BPDU to switch number 3. When it forwards the BPDU to switch number 3, it will say root switch's priority, whatever switch 1's priority is, root switch's priority is 32,768. Root switch's MAC address, I'm just saying switch 1's MAC address as 1111. Okay, advertising switch priority. Now this advertising switch is switch number 2. It will say 32,768 and advertising switches MAC address, which is switch 2's MAC address. Let's assume it as 222. And it will say cost to reach the root switch is 19. So this is how switch 3 will know I am receiving a BPDU from a switch. That means I'm not directly connected to the root switch, because the root switch MAC address and the advertising switch's MAC address are different. And this guy is saying my cost to reach the root switch is 19. That means obviously I'm not directly connected to the root switch. The same kind of BPDU will be received from the other side as well, from this side as well. Switch 4 will say my cost to reach the root switch is 19. And now with this, switch 3 will identify what is its cost. He's saying, this guy is saying my cost is, this guy says my cost is 19. What is my interface cost? My interface cost is 19. So 19 plus 19, that makes me 38. This guy is saying my cost to reach the root switch is 19. What is my interface cost? It is 19. 19 plus 19, that is 38. That is how they're calculating the cost to reach the root switch.
So
Got it?
this will be the process after the root is selected, and then those DP block port for that
Exactly.
also, it will keep on.
Exactly. Yes. First, always a root switch is selected. So in the first few seconds, all of them are exchanging their BPDUs with each other, and they will decide who amongst them is the root switch.
So once the root is selected, then only that
Then
will
everything starts. Then everything starts.
okay. Then only that will send BPDU, and
Only
through
root
that
switch will send BPDU.
it will be okay. So one more thing. So first time what BPDU sent, that will have the third point, that is we're sending advertising switches this and address user MAC address. That will be first time it will be sent, or it will be after the route is selected then. So this third and fourth points. So initially what
Yeah.
BPDU is sent by everybody. So that time they will not have
When
this, right?
initially when they send the BPDU, the root switch priority, root switch MAC, advertising switch priority, advertising switch MAC will be same.
Okay, got
Meaning
it.
for switch number 4, it will say I am 4444. Advertising switch MAC address also 4. For 3, this will be 3333, and advertising switch MAC address will also be 3.
Okay.
But
So after
the
the route is
moment they
selected, then it will
realize
change.
after the root switch is selected, this advertising MAC address and advertising priority will change.
Okay,
But the root switch MAC and root switch priority remains.
that will remain same for that. Got it.
Yes. Yes. All right. So we'll discuss about the timers tomorrow.
Okay, yeah, the timers.
Yeah. Any question till here for this class?
It's clear. So whatever doubt I asked, got it cleared.
All right. All right. Is it okay, the speed or and the depth that I'm going
No,
and explaining?
no, yeah, speed is fine. It is not too fast.
Okay. Fine. Fine. I'll see you tomorrow. Yeah.
Okay, see, yeah, good.
Okay. Yeah. Bye bye. Have a great night.